Okay, in this video we're just going to look a little bit at fractions and then looking at solving a couple more linear equations. A couple things to keep in mind with fractions. It depends on what question you have as to what you do with the fractions. For example, if I say I had 2/3 plus 3/4 and my question was add those two. So to add those, you need to get a common denominator, which is going to be 12. So I need to take the 2/3 and I need to take 3/4 and multiply it by something, so I'm going to have a 12 on the bottom. Well, the first one, it looks like I'm going to have to multiply the bottom by 4 and the top by 4. Okay, so multiply both those, so that'll be 8/12. Plus this one, to get 12, I'm going to have to multiply it by 3. So I multiply 3 on the top and the bottom, so we'll get 9/12. Then now that I've got a common denominator, I can keep that denominator and add the top two. Okay, so that's adding or subtracting fractions. Now, there's a fairly quick way that you can deal with fractions that's different than that if you have an equation. So say I have an equation 2/3 x minus 1/4 is equal to 4, for example. So here I see fractions. I'm thinking common denominator, but one of the rules that you can use with when you have an equation like this one is you can use, I call it the I hate fraction rule, and it's where you multiply each term by the lowest common denominator. And notice that this time I'm not going to multiply top and bottom by the lowest common denominator. I'm just going to be multiplying basically the top. So I'm going to take this one. Again, I have 3 and 4, so the common denominator is 12. So I'm going to multiply this one by 12/1. Often I don't put the over 1 there, I just put the 12. But over 1 is fine too. So I have to multiply each term by that. The purpose of that is doing that is to get rid of the denominator. So, but you can only do this if you have an equation. You can't do this if you're just adding or subtracting fractions. Can't do. So here 12 times 2 is 24, divided 3 I think is 8. 12 times 1 divided by 4 I think is 3, is equal to 12 times 4 is 48. And then I'll add 3 to both sides. So I'll have 8x is equal to 51, and then divide both sides by 8, so I get 51/8. Okay, so that's a distinction between when you multiply top and bottom by something, and you do that to get a common denominator so that you can add or subtract, versus if you have an equation, there's just a little trick. What do you call it? You're multiplying by the same thing. I should remember the name of it. It's early in the semester. Anyway, the rule is if you multiply everything by the same term, it doesn't change the equation. Okay, and if you multiply by the right term, you get rid of all the fractions. So now I have no fractions. I can just simply solve that linear equation. Okay, here's a couple more linear equations that we can solve. No fractions, I breathe a little bit easier, but I have brackets. So the first thing I would do with brackets is get rid of them. Look to see if you can combine anything inside. I can't combine those because one's an x and one's a number. But if I have a number out front, I can use the distributive property to multiply that through. So 7 times 3 would be 21x. 7 times 6 is 42, is equal to 11. And now this thing here, if there's a negative sign in front of a bracket, I call that the dirty, rotten, filthy, stinking negative, because I have to apply that negative, just like I did with the 7, but I have to apply that negative to both things inside the bracket. So it'll be a negative x and a -2. That -2 is where lots of students mess up. Okay, now I have to, on this right side, I'll just leave this side alone. But on the right side, I can combine the 11 and the 2. So I'll have a -x, and 11 take away 2 is a +9. Now I want to get x's on one side, numbers on the other side. So I'm going to add an x here, so they cancel. If I add it there, I have to add it there. So I'm going to have 22 x's plus 42 is equal to 9. Now I want to get rid of that 42, so I'll subtract 42 here. That'll get rid of it. If I do it there, I got to do it over here. So I'm going to have 22x is equal to negative 42 plus 9, or 9 take away 42. I'm calling that negative 33, I think. Now we'll divide both sides by 22. So I'll have 22x equals negative 33. Divide by 22, divide by 22. So I'll get x is equal to negative, and then 33 divided 22, I think I can simplify that. I think 11 goes into both of those. So 33 divided 11 is 3, 22 divided 11 is 2. Okay, so that's how you'd solve that question with brackets. One last one. Oh, crazy brackets. Okay, so here's a bracket and there's one, but then here's some inside. So I'm going to work in here first. So I'll leave the 2, square bracket 9. Now I'm going to take this negative 3 and multiply it by both things inside the brackets. So it'll turn out to be a positive 6x. Negative 3 times negative 4 is a positive 12, is equal to 12x plus 42. Notice when I multiply that the bracket goes away. So these curly brackets are gone. Now within here, I can combine the 9 and the 12. So 9 plus 12 is 21, plus 6x is equal to 12x plus 42. And then I'll take the 2 and multiply it inside. Because it's outside, I can use that distributive law. So it'll be 42 plus 6x is equal to 12. Oh no, I made a mistake there. Whoops. 2 times 6 is 12. Where's my eraser? Eraser. That doesn't look like an eraser. There we go. 12x. Oh, I have both sides exactly the same. Everything's going to cancel out. Let me just follow that through to make sure. So I'll subtract 12x here, subtract 12x here. So on this side I get 0x, or just 0. Nothing. Those cancel. These cancel. So I have 42 is equal to 42. Since that's a true statement, and this is a funny equation when everything cancels out like this, if this is a true statement, then what you can say is your solution is x is equal to any real number. Sort of a funny kind of answer to the question, which basically says if I'd have plugged any number I wanted in for x there and in for x there, I would get the same thing on both sides. All right, hopefully that helps you with those couple of questions.